Friends, today we study reactor performance. What are the decisions we can make for choosing a proper reaction for the product and that is to be used in the plant or a project. Now we see there are three basic types of reactions are available in chemical industries. We can see there is a polymer reaction, then there is a biological reaction, biochemical reactions, then the chemical reactions. Now, for selecting reactor performance, we should know what are the reactor performance is required for that process. Now, for polymerization reaction, the main concern is the characteristic of the product. Now, what is the product? Now, in polymerization reaction, the product is concerned by the three parameters, or we can say the various parameters is useful for the polymerization reaction is the distribution of molar masses of the polymer product, then the orientation of groups along the chain, cross-linking of the polymer chains, copolymerization with a mixture of monomers, and so on. So this is the main consideration while selecting the polymerization reaction. Now for in this type of reaction, the main concern is the mechanical properties of the product. Now the second type is the biochemical reactions. Now in this, the performance of the reactor will normally dictated by the laboratory results. So because of that difficulty predicting the such reaction theoretically, there are likely to be constraints that on the reactor performance by the biochemical process. So in this manufacturing example, manufacturing of ethanol using microorganisms, the concentration of ethanol rises, the microorganisms multiply more slowly until a concentration around 12%, it becomes toxic for the microorganisms. So these are the decisions we can make for a biochemical reaction. Now other types, rather than the polymerization reaction and the biochemical reaction, there are generally chemical reactions. In chemical reactions, we have to consider the three important parameters. So that is the performance can be measured. So three important parameters are conversion. So that is the nothing but the ratio of reactant consumed in the reactor to the reactant fed to the reactor. Second parameter is the selectivity. Now what is selectivity? It is the parameters. It is a ratio of the desired product produced to the reactant consumed in the reactor multiplied by the stoichiometry factors. Then the third performance is the parameter is the reactor yield. So it shows the ratio of the desired product produced to the reactant fed to the reactor multiplied by the stoichiometric factor of the reaction. So these are the three parameters that can be used to measure the performance of the reactors. Now we can see how it can be used. Now we can see one example for that. So how these three parameters can be used for the for calculating the performance of reactor. Now we can see the example. The benzene is to be produced from the toluene according to the reaction. So toluene is reacted with hydrogen, which gives the benzene and the methane. Now some of the benzene undergoes number of secondary reactions in the series and unwanted byproducts that can be characterized to the diphenyl and the according to the reaction. So for the reaction, so benzene is again can be that is can give diphenyl. So that is the side reactions or the byproducts can be produced. Now from here, from this example, we can find out the performance of reaction by considering the three parameters. Now what is given here, we can see the composition of the reactor fed and the effluent stream. Now we can see reactant feed and effluent stream. H2 is given to the reactor kilomole per hour, then the output of that H2, again methane, again output of that methane, then benzene, output of the benzene, then the diphenyl, then output, then all these things are can be given, that is given in the reactor. So what it shows that there is a reactor where can feed toluene and hydrogen, which will give benzene and methane. So the inflow flow rate of the benzene and flow rate of toluene and flow rate of hydrogen is fed to the reactor, and output flows are given. So that is given. Now what we have to calculate is to calculate the conversion selectivity reactor yield with respect to the toluene feed and the hydrogen feed. So from here we can calculate the performance of reactor. Now from the solution we can see here for toluene the conversion can be calculated by the formula toluene consumed to in the reactor, that is upon the toluene fed to the reactor. So consume will be what we can see, consume will be fed and output. So minus of that, the difference between that can be toluene fed to the reactor, consume in the reactor, then the toluene fed to the reactor. So we can see the conversion is 0.75. Now the stoichiometry factors are 1, so we can calculate the selectivity as benzene produced in the reactor to the benzene consumed in the reactor. So benzene produced we can calculate by considering difference of this, then the benzene toluene consumed in the reactor, it is the same value, so we can get the value selectivity 0.96. Same thing we can do for reactor yield. So benzene produced in the reactor, toluene fed to the reactor, we get a 0.72. It means 75 conversion, 75% conversion is there. Selectivity is 96% and the reactor is 72%. That are the results we get from the calculations. Again we can, there are two feeds, so we can calculate with respect to hydrogen also. So for hydrogen we can calculate conversion is 0.5, that is 0.15, that is 15% conversion is there. Then the selectivity is 98, then the reactor yield is 0.4. So this is the with respect to the another feed that is called as a hydrogen. Now we can make a decision based on the calculation is that because there are two feeds to this process, the reactor performance can be calculated with respect to both the feeds, but the main concern is the performance of toluene. So we have to consider that because it is more expensive than the toluene, that is hydrogen. So we have to consider we have to take a decision by the calculation based on the toluene. So in describing reactor performance, selectivity is more meaningful parameter than the reactor yield. So we can see the reactor yield is based on the reactant fed to the reactor rather than the which is to be consumed. So part of the reactant fed might be material that has been recycled rather than the fresh feed. So the meaningful characteristic is selectivity. What it shows, that what is selectivity we can see from the diagram, from the that is the formula. We can see that benzene produced in the reactor upon the hydrogen or whatever the reactant is consumed in the reactor. So main concern is how much reactant is fed, how it is consumed, and what are the products are produced. So we can, based on the selectivity, we can make a decisions on the reactor performance. Again, reactor yield can give the various results also. Now reactor yield takes no account of ability to separate the recycle unconverted raw material. Reactor yield is only meaningful parameter when it is not possible for one reason to recycle the unconverted raw material. So these are the three basic that parameters that is to be used. So first we have to calculate the conversion of the reactor, how much conversions can be take place, what is the selectivity, that means whatever the feed is fed to the reactor, how it is consumed, and what is the product, how much product is produced. Again the reactor yield also is there. So three parameter, from that three parameter we can consider the selectivity, that is very useful parameter by selecting the reactor parameters. So that is the first thing for calculating. Second thing, first we have seen the reaction path, second thing is the three parameters. So from this calculation we can make a decision, that is the reaction is feasible, or we can go for the further for the manufacturing that is the decisions can be made before the reaction has been started or the project has been started. So these are the basic things that are used in the literature survey before actual going to the plant or actual going to the actual process. So that is the decisions, or that is also called as a decision making, or the decision making based on the fundamentals of the reactions. So that is how we can make a decision. Thank you friends, thank you for your attentions.